So as we move through chapter 10, here's another definition of acids and bases. We originally said, well, acids donate H plus and bases accept H plus. Well, the other definition is, what if you just put it in water? ARRHENIUS said, just put the stuff in water and see what happens. Well, the strong acids donate an H plus to the water. They get that and that. Weak acids donate H plus to water. I get that and that. So all acids in water produce H3O plus. Now, one way to think about that really is they'll say, well, that H plus dissociates from the acid. Now, where it dissociates to is, well, it's a little bit of a fib, but it's sort of reasonable to say, well, this comes off the acid and then sticks to a water molecule. It's a little bit of a fib, but it's not bad. The difference between strong and weak is simple. If you look at the strong acids, there's no real equilibrium. It's just, that's it. You put them in water, they get rid of their H plus. There's no equilibrium to consider. For weak acids, we have an equilibrium situation. Okay, in water, H3O plus, strong, weak. Bases get there a couple of different ways, but you'll certainly notice OH, 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 OH. That's hydroxide, right? So every single one of these somehow makes hydroxide in water. Now, the strong bases up here, that's chapter 3. Those are ionic compounds. Ionic compounds with hydroxide, with OH minus. Now, the weak bases get there a couple of different ways. You'll notice, hey, there's nitrogen in a compound, nitrogen, nitrogen. So we'd say, well, they all tend to have nitrogen. So we'll say nitrogen compounds. We're going to refine that a little bit more. The other thing down here, there's no nitrogen, but those are basic. Cn minus, F minus, HClO3 minus. So the other thing we mostly see, anions. So the strong bases, simply the OH comes off in water, there's hydroxide. The weak bases have to somehow do some trick here. Let's look at the next page and we'll summarize this. Strong and weak. This has come up before. We just have to have these memorized. HCl, HBr, HI, HNO3, HClO4, HClO3. Those kind of get used interchangeably. And lastly, one that's a little bit complicated, H2SO4. When I put those in water, 100% of the H pluses dissociate, break off, and stick to water molecules. Now, the weak acids are basically all other acids. HF, HNO2, HCN, and so on. Now, there's one I want to point out. Acetic acid, H, CH3, CO2. This is often written CH3, COOH. Now, the acidic hydrogen is over there, but so if you see something that they're talking about it being acidic, but you don't see a hydrogen in front, it's this acetic acid exception. Strong bases contain hydroxide. So that's in an ionic compound. sodium hydroxide, magnesium hydroxide, aluminum hydroxide. I know that's a strong base. It sort of directly donates OH minus to the water. Now, the weak bases do this a little bit differently. If I put nitrogen, a neutral nitrogen compound in water, what it does, if I write my water like this, those electrons sort of pull an H plus off. Well, when I pull the H plus off, I'm left with hydroxide. So nitrogen compounds can produce hydroxide by pulling an H off of water. Same mechanism for anions. They're negative. They'll do the same thing. They'll pull an H off of water, which leaves hydroxide. So the mechanism, I think, helps to understand. Okay, we're going to come back to pH extensively, but just to kind of give us a little basis to talk about this, we're going to talk about acidic, neutral, and basic solutions. And I suspect you have an idea about neutral. There are shampoo bottles at our house that say pH neutral. What is pH neutral? What is that number? It's 7. We're going to get to why it's 7, what that means, what the math is for that. But you probably have an idea from somewhere that pH neutral is 7. When things are acidic, they're less than 7. So we'll say, well, if the pH value is less than 7, we're going to say that's an acidic condition. If the pH is basic, we say the pH value is greater than 7. We're going to come back to that and look at this in great detail, but for now, we just would like to know that. Now, I have a summary on page 11, 1011, that sort of ties all this together. And again, we're saying if I make a solution, it just means put something in water. Put a compound, an ion, whatever in water, and does it make an acidic or basic solution? Well, strong acids, no surprise. The strong acids that we memorized make acidic solutions. Oh, wait a minute. Sorry, I got ahead of myself. I've only had one cup of coffee today. Let's just say acids. We won't say strong acids, so we'll strike the word strong. Just say acids. Oh yeah, they start with an H. They're the acids. Things that produce basic solutions, these are ionic compounds that have hydroxide, like we just said. So ionic compounds containing hydroxide, containing OH minus. No surprise. Acids produce acidic solutions. Compounds that have hydroxide produce basic solutions. Now here's another series of substances. Notice they have something in common that produce basic solutions. Well, anion, 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 anion. These are all anions. Anions tend to produce basic solutions in water. Again, if there's a water molecule, HOH, anions tend to pull the H off, which leaves hydroxide behind. So most anions produce basic solutions in water. If I see an anion, I should think it's likely that that is going to produce a basic solution in water. Now, there are a handful of exceptions here. Chloride, bromide, iodide, nitrate, perchlorate, sulfate, hydrogen sulfate. What do all those have in common, and why are we leaving them out? These are all conjugate bases of I'll pause for a minute and think, well, wait, what is that? Those are conjugate bases of the strong acids. Strong acids get rid of their H+, and they just don't take it back. Once they've got rid of their H+, they won't pull an H+ off water to produce hydroxide. So most anions, if I see an anion, my immediate response should be, that's going to be basic. Oh, wait a minute. There are about 6 exceptions to that. Now, let's go down here. What do all these compounds have in common? Again, these are all substances, compounds, ions that give me basic solutions. Come down here and I say, well, these are all neutral compounds that contain nitrogen. And again, if I think of a water molecule like that, you go, well, yeah, that H+ could come off and form a coordinate covalent bond with nitrogen. Well, if that pulls that off of water, then bingo, I've got hydroxide there. So we'll say, we have to be very careful about this, neutral molecular compounds that contain nitrogen. So anytime I see a compound that has nitrogen, it's neutral, covalent, 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 molecular, 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 molecular. There's a nitrogen in there that looks like that. I know that this could be basic. Now, I have this other set over in my acidic column. Acids produce acidic solutions. And I have this over here in the acidic solution. How are these related to these? Well, these are all conjugate acids of weak bases. So no surprise, these are basic. Their conjugate acid form is going to be, guess what? Acidic. So we can say this several ways. These are all cations, right? That contain nitrogen. And the nitrogen in each of these cases looks like that. We normally expect a lone pair of electrons to be hanging out on that nitrogen, but that nitrogen's had an H+ added to it. So this is now acidic. It can donate the H+ back off. And again, I'll make a note. These are conjugate acids of compounds that contain nitrogen like that. You put an H+ on there, it's acidic. Take the H+ off, and it's basic. All right, now we've got a bunch of practice problems on page 10.12. Now what I would recommend is you go through these and try them, with pencil maybe, and then we'll come back and I'll go over the answer. So pause the video, do those. All right, you paused it, right? Well, I'm going to do the easy ones first. I see H+, 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 H+. Acidic, 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 and acidic. Now I've got sodium bromide, and I go, well, I don't know. I've got sodium, and I've got bromide. I don't really have any rules for cations like that, so I sort of go, well, I'm just going to ignore that. Oh, we should think anions make basic solutions, right? So I say, oh, there's an anion. I should say basic. Why not? That's the conjugate base of a strong acid. This is actually neutral. KOH. What I'm seeing there is hydroxide. Number 6, hydroxide. So I think, oh, that's easy. That's hydroxide. Basic, basic. And I'm going to write OH minus, OH minus. Sorry about the cough. I'm fine. I just had a tickle in my throat and I didn't hit the pause button in time to not record the cough. Excuse me. Okay. Sodium, no rules. Perchlorate, I think. Basic. But you know why. No, that's actually neutral. Now, ammonium chloride, what I've got there is ammonium chloride. Chloride, I think, basic, but oh no, that's the conjugate base of a strong acid. Nope, I don't think about it being basic. But I look at that and I go, oh, there's my conjugate acid of NH3. That's acidic. Similarly here, ammonium nitrate. Nitrate's not basic, but ammonium certainly is acidic, NH4 plus. Here I just don't see anything going on. This isn't broken up in water, but I recognize that nitrogen right there. Chapter 4, we probably went in carbon, nitrogen. That's what that little bit looks like. And I think, oh yeah, those electrons could pull an H plus off of water, leaving OH minus, and that's basic. So some of these look exactly like acids and bases we've seen before. There's no surprise, oh yeah. But sometimes there are things that don't really look like acids or bases, but we have these new rules to say that if you put that in water, it's going to be acidic or basic. That sort of wraps up this identification of acids and bases by sort of, we sort of just put them in water and see what they do. The next thing we're going to do, when we put acids and bases in water, it allows us to sort out this strong and weak stuff. So that's the last part of this week's lecture in Chapter 10 is, if I put them in water, which ones are strong, which ones are weak? Can I rank the relative strength of acids or bases that we would call weak? All right, hang in there, folks. We're almost done.